All right, I'm going to do some examples from lesson 2-1 on slope-intercept form. And I'm going to do a couple of finding slope-intercept form from 2 points at the end. So I know those were ones that are probably really tricky for you guys. And I guess I'll do these graphs as well. All right, so how are the graphs of y equals 2x plus 1 and y equals negative 2x plus 1 similar, and how are they different? Okay, so they look almost the same, but the difference here is that the number in front of x, which is m, if you look at the equation y equals mx plus b, this number here in one is positive and one is negative. So this equation has a positive slope because m is our slope. So on our graph, it's going to be going up. This one has a negative slope. So remember, you always read these left to right. So negative is this way. This did have a few of you tripped up still because a line does go both directions, but you're reading the graph from left to right. So left to right, this is going up and this is going down. All right. And we want to graph a couple of equations here. So I have y equals 2x minus 5. Remember, this is mx plus b. So m is 2 and b is negative 5. This is my slope. This is my y-intercept. So I'm going to start at negative 5 and go up, which means I need some negative numbers, but it's also going to go up. The first time it'll go to negative 3 because I'm going to add 2. So I can still have pretty much everything down here in the negative. So I'm just going to put this as my x and this is my y. Yours doesn't need to look exactly like this, but you do need lots of negative space since we're starting at negative 5. So here's negative 5. And let's say 1, 2, 3, 4, 5. Then I'm just going to go up 2 and over 1. Remember, if it's a whole number, if it helps you, just put 2 over 1. Up 2 and over 1, and it's always over to the right. I always say over 1 because of the fraction. It just makes sense in my head. But you got to remember that you're graphing to the right. The next one, we're going to start at positive 2 and go down 3 over 4 because my slope is negative 3/4. My y-intercept is 2. So I'm going to start in the positives, and that means that I need some positive values. I can't, if I had this graph, it wouldn't have worked. So I need a little more space here. So here's 1, 2, 3, negative 1, negative 2, negative 3. Oops. Okay, so I'm going to start at 2 on my y-axis, and then I'm going to go down 3 and over 4 to the right. 1, 2, 3, 1, 2, 3, 4. You can also think of this as going down 3/4 of a square each box, but that's a lot harder to graph. So it should look like that. All right, the next ones we're going to write the equation of each line from slope-intercept form, or in slope-intercept form from this graph. So you're going to look for where your y-intercept is, and then you're going to count down and over to where the next time that it hits a corner is. Remember when you do those slope triangles, you don't want to find where it hits in the middle of a box. You know, how are you going to estimate what that means? You want to look for where it's crossing at a corner because you know that that's a whole number. We don't want to mess with these like that might be a half of a box or 1/3 of a box. I don't know what that is. So you count your slope triangles down and over to where it hits another corner. So this equation has a y-intercept of 1. And I'm just going to double check because I want to make sure that each box is just a value of 1 before I decide that. See, there's a 3 up here, so 1, 2, 3. This is -2 and it's back 2. This is +2 and it's forward 2. So each box is worth 1 in this graph. So that means that it starts at a +1 and it goes down 2 over 1. So my slope is -2 over 1, or you can just put -2. So this equation says y equals -2x plus 1. The y-intercept is here, and the slope is here. And we'll do the same thing with the next equation. It's starting at -2, and it's going up. Up 1, 2, 3 over 2 until it hits another corner. So it's y equals 3/2 x minus 2. There's the y-intercept, and there's the slope, up 3 over 2. All right, these I'm going to do on a separate piece of paper because it is going to take a few steps. Remember, we're going to find the slope first, and then we're going to plug it into slope-intercept form to solve for our y-intercept. All right, so we have question 11 was 3, 1, and 0, -3. This is finding slope-intercept form from 2 points. Okay, both of these points are on the same line. You could graph it, and you would see about what it looks like. But when we solve things algebraically, it's always going to be more accurate. Graphs are always going to be an estimate unless you're using some kind of program to graph it for you, which had to be programmed by somebody who's really good at math. So that's why, you know, the people who know how this stuff works make so much money. Anyways, first thing we're going to do is we're going to use slope formula, which is y2 minus y1 over x2 minus x1. And that'll find our slope. And then we're going to plug in the slope and one of our coordinates to solve for b, just like we did in class. So if I say this is x1 and this is y1, this is x2, this is y2, then I plug it in that way. Remember, you could say this is x1, y1, and this is x2, y2, and you'll still get the same answer, I promise. Isn't that right, Jack? Yeah. He says so too. So we're going to do -3 minus 1 over 0 minus 3. -3 minus 1 is -4. 0 minus 3 is -3. Since they're both negative, we're just going to make it positive, 4/3. And that is M. Now you can take either of these coordinates and plug it in as X and Y, but you can't take X from here and Y from here. That's come on. You have to take X and Y from the same coordinate. I'm going to use these just because they're positive numbers. And hopefully I'll be able to multiply this by 4/3 and cancel out that 3. So that's nice. So this is going to be Y, and this is going to be X in my equation, and then I'm going to plug this in for M. So 1 equals 4/3 times 3 plus B. Okay, I plugged in 1 for Y, 4/3 for M, and 3 for X. Now I can solve for B, and the first thing I need to do is just go ahead and multiply 4/3 times 3. Remember, this is 4 divided by 3 and then times 3. So look, it's just going to cancel out. So I get 1 equals 4 plus B. It's positive 4, so I subtract it. And I get -3 equals B. Now I have my y-intercept and I have my slope. Remember, when you write slope-intercept form, y and x are any coordinates on the line, so you do not put in numbers for those. You leave those as variables. You plug in your slope and your y-intercept, and you can put plus -3, or you could just put -3. And that is the final answer. Okay, and we'll do one more. This one is -1, -5, and 2, 4. If you feel like maybe you get it, I would pause the video, try to do it on your own, and then start the video again and see if you did it the right way. See if you got the right answer. So first thing I'm going to do is 4 minus -5 over 2 minus -1. So these both become plus, and I get 9 over 3, which gives me M equals 3. Then I'm going to take the positive coordinates just because to me it's easier to keep them positive, and I'm going to keep my slope. So 4 equals 3 times 2 plus B. So I plugged in y for y, x for x, and m for m. 4 equals 3 times 2 is 6 plus b, and then I just subtract the 6. And I get -2 for b. Now I can just write my equation, y equals 3x minus 2. And that's the final answer. If you are still stuck on anything, if there's anything that you don't feel like we covered completely in class, just message me and I'll make sure we cover everything a little bit more on Monday. Have a good weekend, guys.